Welcome to the DLC network on future-proofing energy efficiency with network lighting controls. We're going to wait just a minute or two as more people are joining, and then I'll get started very soon. So thanks for joining in. Okay, let's go ahead and get started then. Welcome everyone to this webinar on future-proofing energy efficiency with network lighting controls. My name is Levin Nock. I've managed research on emerging technologies and worked in the field of energy efficiency for more than 14 years, including 7 years of helping the DLC support networked lighting controls. I'm here today to tell you about the results of research that the DLC recently commissioned that was completed by Matthew Sachs and Samartha Mohan of NV5. As you think of any questions, please put them in the question and answer window as opposed to the chat window. My colleagues Stuart Brzezinski and Andrew Antares will respond to some of them in the window, and also at the end of my presentation will help me address the contents of questions that are still open then. The DLC launched this research project to explore the place of network lighting controls in energy efficiency programs of the future. We've heard that lighting incentives are disappearing, residential now, and maybe commercial soon. We've also heard that with energy efficient LED lighting, controls do not save enough electricity to be worth the cost, or to be significant compared to heat pumps. Commercial lighting is more efficient than it's ever been. Even if a network lighting control system saves roughly half of the lighting load in a given space, that load is smaller than it used to be, so the energy savings are smaller. Also, large-scale industrial solar energy has become very affordable. When incentive programs buy energy efficiency, the value of saving energy depends on the local cost of providing energy. For instance, in Connecticut in the Northeast, electricity is expensive, so efficiency programs can afford to pay for energy savings that are expensive. On the other hand, inexpensive solar energy is readily available in Arizona, so the average price paid for energy savings in Arizona is only around 20% of the price paid in Connecticut. On the other hand, ACEEE recently published a report showing that the value of energy savings from energy efficiency is likely to rise over time as the penetration of renewable energy rises. In other words, energy efficiency measures that are valuable today will deliver even more value over time. In 2018, lighting accounted for 10% of the energy used in commercial buildings, and it's gone down a little since then. By installing network lighting controls, you can save half of the lighting load, saving around 5% of the energy used in a typical commercial building. Would that be significant? Maybe, in some situations. However, suppose you manage to provide occupancy signals from the network lighting controls to the system controlling heating, ventilation, and air conditioning, or HVAC. Then you could save 30% of the HVAC energy. When you install luminaire level lighting controls with embedded sensors, all those sensors get powered by the wiring for the lights and wirelessly networked when the lights are configured. When you're replacing luminaires anyway, The extra effort to install network lighting controls with embedded sensors is pretty minimal. Compare that to the major cost and effort to upgrade building envelopes or replace major HVAC components. Then suddenly the NLC system looks very appealing. NLC could significantly improve the operations of existing HVAC equipment quickly until that HVAC equipment eventually gets replaced and upgraded at the end of life and comes up to code. The total bite out of the commercial energy load from lighting plus HVAC could be as high as 22% just from network lighting controls. If you could scale that across many commercial buildings, that would take a big bite out of energy use. This research addressed the question, are incentives for network lighting controls still good investments for electric energy efficiency programs? The short answer is it depends, but yes, in many circumstances, they are good investments. There is a related question about whether network lighting controls are good investments for owners of commercial buildings. While that is an important question, it is not the subject of this research. These results today are only from the point of view of energy efficiency incentive programs. These programs are affected by various local and regional conditions. For this computer model, we picked Connecticut and Arizona as examples of those conditions in two different parts of the US. We drew from several different data sets to model the energy usage in all the commercial buildings of each of those two states. We assumed in the model that lighting gets updated about every 10 years on average. The energy savings from simple wattage reduction with a lighting retrofit was not reported because we know that's going to happen anyway. We explored scenarios that said at the time of a lighting upgrade, suppose you also added network lighting controls. How much energy would the controls save? First, by controlling the lights, and then suppose you also offered demand response capability, either automated for medium and large buildings or a manual scene control with a text message for small buildings. For medium and large buildings, suppose you controlled some plug loads. And for large buildings, where customized programming for BACnet or API is feasible, suppose you offered occupancy signals for HVAC. We also asked a separate question. What if some lighting upgrades do not get lighting controls right away? If those upgrades could require controls-ready luminaires now with standardized digital D4i drivers and Zaga sockets for sensors, and then the luminaires get standardized controls added 5 years later, how much energy would that save? And since there's a 5-year delay, we ran that scenario up to 2035 to catch the energy savings from the delayed control installation. We divided buildings into 3 sizes, with small less than 25,000 square feet, medium between 25 and 50,000 square feet, and large more than 50,000 square feet. Many buildings are suitable for NLC HVAC integration to change the ventilation rates and temperature set points based on occupancy, but some are not, depending on the type of building, variability of occupancy patterns, size of HVAC zones, and availability of either a building management system or digital HVAC controls with remote access. For ventilation savings, the system needs to be designed for variable air volume. Also, until there are better standards to match up the names of lighting zones with the names of HVAC zones, it helps if the building is large enough to justify customized software that is different for every different building. We rolled all that up into a rough estimate of 60% of buildings over 50,000 square feet. That number could be refined in future work based on some of those granular details. But for now, we included 60% of buildings over 50,000 square feet because that's how many already have a building management system. There could be more potential value in expanding the measure to medium and small sized buildings in the future when that's more of a plug and play process. As I go through these results for Connecticut and Arizona, please bear in mind that the same method could be applied to other regions that want to sponsor similar research. If you're interested in getting results specific to your own region, please get in touch with DLC with an email message to info@designlights.org. Now I'll show you the main results addressing the question, what makes incentives for network lighting controls a sound investment for efficiency programs? We found that when lights are being updated anyway, adding an incentive for network lighting controls makes sense for a utility in some buildings, but not others. When you add demand response, you pick up a few more building types. But to take a big bite out of energy use, you can add HVAC control in large buildings. Since Connecticut can pay more for energy savings than Arizona, more building types were covered in Connecticut. Still, in both states, there's the same trend. Network lighting controls alone are good for buildings with a high lighting power density and variable occupancy. Adding demand response picks up a few more building types, and adding HVAC integration to large buildings picks up all or nearly all of the remaining large building types. By the way, plug load controls turned out to be expensive and not very helpful. Turns out that many modern plug loads in commercial buildings already have a sleep cycle to save energy, and the ones that do not are not necessarily amenable to outside control. To see the relative cost of these options, this chart is normalized to the average price paid per unit of energy savings in Connecticut. That is defined as 100%, as you can see with the blue bar here. The green bar shows that compared to Connecticut, Arizona only pays about 20% as much for each unit of energy saved. Saving energy with network lighting controls, either alone or with demand response, costs a lot more than the average price of saving energy in either state. Saving energy with network lighting controls integrated with HVAC controls in Connecticut is a little cheaper than the average cost of energy savings in Connecticut. The price in dollars per unit is about the same in Arizona, but the average cost of energy savings in Arizona is low, so NLC HVAC integration costs about 4 times more than the Arizona average. Now that we've seen the difference between the high price paid per unit of energy savings in Connecticut versus the low price paid in Arizona, we can review the results in terms of the building types where network lighting control incentives are cost effective in each region. This picture shows the main building types that we modeled. This picture shows small buildings under 25,000 square feet on the left and large buildings over 50,000 square feet on the right. Most of the building types are shown on both sides, except that nobody builds restaurants larger than 25,000 square feet. For simplicity, medium-sized buildings are not shown in the diagram. In the model, the medium-sized buildings between 25 and 50,000 square feet behaved like the large buildings, except that HVAC integration was not considered available because it's not a plug-and-play scalable solution yet. In Connecticut, when installed along with a lighting upgrade, but without demand response or HVAC integration, network lighting controls are cost-effective in most small buildings, plus large retail and hospital buildings that tend to have a high lighting power density with lots of bright lights. The benefit-cost ratio is in the range from 1 to 3. If we add demand response, then we pick up a few more building types, small warehouses plus large office and outpatient. By integrating NLC with HVAC controls, all of the remaining large building types are added. Using the utility cost test to evaluate NLC HVAC integration in Connecticut, the benefit-cost ratio in most building types varies between 3 and 6, which is a delightful range to be in, where the value of benefits is significantly larger than the cost. In Arizona, the results are still positive but less rosy. Incentivizing network lighting controls during a lighting upgrade really only makes sense in quick-serve restaurants and retail, where the lights are very bright. Adding demand response picks up one more building type, small hospitals, again with plenty of bright lights. But when you add HVAC integration to large buildings, now network lighting controls incentives are viable in all of the large buildings except for warehouses. The benefit cost ratios in Arizona varied from 1 to 3, which is a useful range, but less amazing than the 3 to 6 range for HVAC integration in Connecticut. To look at these results from a different perspective, an incentive program for network lighting controls with HVAC integration can serve more utility customers in more types of buildings, compared to the narrow relevance of standalone NLC programs that are only feasible in a few building types that have lots of bright lights. This is another perspective on the data, with electricity savings broken out by building type along the x-axis and savings for lighting versus HVAC equipment in the colored bars. The total height of each bar shows the energy savings in each type of building for all of the commercial buildings in Connecticut from adding network lighting controls. Lighting savings are shown in yellow. In the large buildings where HVAC integration was feasible, the other colors show cooling in dark blue, fan ventilation in dark green, and heating in light blue. By the way, to get a sense of scale, the maximum value on the y-axis of 250,000 megawatt hours is a little over 2% of all Connecticut electricity sales in 2020. As you can see that in Connecticut, a program could choose to catch significant savings by focusing on NLC HVAC integration in a few types of large buildings over on the left-hand side of the chart. Alternatively, a different program could serve more customers by installing network lighting controls in many different types of buildings. And this chart doesn't even show the savings from heating by natural gas, where occupancy controls can help save on gas utility bills. Take a look at the long tail on the right that's mostly yellow. The small and medium-sized buildings that are all yellow could get a big boost in energy savings if we could add some blue and green HVAC savings there too, like in the large buildings over on the left. The market is not quite ready yet with a plug-and-play scalable solution, but it could be in a few years with some effort. Here's a comparable chart for Arizona. The maximum value on the y-axis here of 400,000 megawatt hours is 1.4% of Arizona electric sales in 2020. Compared to the Connecticut chart we just saw, there are fewer building types in Arizona where NLC incentives are feasible. Also, you can see that the HVAC savings in blue and green in large buildings comprise most of the savings, with only a little bit of energy savings from lighting shown in yellow. This chart addresses the question, would the benefits of network lighting controls be large enough for a utility to notice? The chart shows the cumulative benefits through 2030 if these two states manage to acquire all of the savings from network lighting controls that their guidelines define as cost-effective. The top blue bar shows that energy savings in Connecticut would be valued at nearly 10%, as normalized by all the electricity sales in Connecticut, commercial, industrial, and residential, in 2020. Arizona would save roughly 5% compared to their total 2020 sales of electricity. We're comparing the value of 1 year of sales versus 6 years of savings, but this gives you a rough sense of how big this number is. There's also a little savings on natural gas and on summer peak demand. This is not an enormous impact, but it would be noticeable. Efficiency programs would deliver net energy benefits valued at $217 million in Arizona and $1.2 billion in Connecticut. That would be big enough to notice, especially for states that have 2030 targets for decarbonization and electrification. Another way to look at those energy savings is in terms of the total greenhouse gas emissions avoided over the 6 years from 2024 to 2030, as estimated by the EPA Greenhouse Gas Equivalencies Calculator. In Connecticut, the energy savings would cut the same emissions as building 35 wind turbines that year and running them for the next 6 years. In Arizona, the energy savings would cut the same emissions as building 47 wind turbines this year and then running them over the next 6 years. The value in dollars is lower in Arizona because energy is cheap there, so the price of energy savings is low. But the energy savings in terms of gigawatt hours and avoided emissions are higher in Arizona. So that's why Arizona would be like building 47 new wind turbines this year compared to 35 in Connecticut. In yeah, so there is of course one flaw in this comparison because new wind turbines need new infrastructure, new transmission infrastructure that may take years of permitting and investments to bring online. While energy efficiency, on the other hand, actually frees up existing transmission capacity to be available promptly for other uses. So in that sense, the energy efficiency savings are even more valuable than if you had built the wind turbines, if you had managed to get them all online this year. Over the past several decades, commercial interior lighting has gone through a series of updates for energy efficiency. The next chapter in that saga is likely to be connections between network lighting control systems and HVAC systems in large buildings now and hopefully in smaller buildings as soon as new standards and practices make those connections easier and scalable. I mentioned that we also looked into a controls ready scenario. This is where long-lasting LED luminaires installed today would be ready for network lighting controls that could be installed later. By 2035, that solution could deliver similar cumulative energy savings if controls are added to those controls-ready products by 2030. That would mean installing luminaires today with digital D4i drivers and Zaga sockets, so that wirelessly networked sensors and controls could be added later easily without the compatibility issues of outdated analog technology. When controls are added, then the new network lighting control system could even get integrated with HVAC controls. This timing is a challenge because some efficiency programs focus on first-year energy savings, or else efficiency targets over a 3 to 5 year plan. From a perspective of less than 5 years, the controls-ready idea makes no sense. Without a new regulatory framework, those programs will continue to install unconnected LED lighting, locking out network lighting control energy savings for the lifetime of 10 years or more of the new unconnected lighting. That's okay, unless a region has any 2030 targets for decarbonization and electrification, in which case energy savings and emissions reductions that are out 5 years or more could become very valuable. Now we'll pause for a poll. So for anyone listening who's involved in an efficiency program, please select the timescale that your program runs on. And I think the poll will be launching soon. Looks like 43% of people have voted. Let's wait a few more seconds to see if anybody else is involved in an efficiency program and still wants to vote. Looks like we're about set then. Thank you for voting. And looks like oops. Sorry about that. I am still chasing down the right go to Windows poll. Well, thanks for that. Let's move on to the next question, which is, if you're involved in an efficiency program, would the delayed timing of energy savings from controls-ready lighting projects be compatible with your regulations? And could another organizer please check in? I'm sorry, I'm not having visibility on the poll at the moment.
Oh, sure, Levin. Hi there, everyone. This is Andrew Antares. It looks like about 41% of people have voted. We've got 17% yes so far, 24% no, and almost 60% maybe.
Great, thanks. Oh, and could you also read the results from the first one?
Oh, sure. I can also, after we close this poll, I can share them on the screen.
Great, yeah, let's go ahead and close that. It seems like about 40% was the number that of people associated with efficiency programs.
Great, yeah, we just hit 45, which is the same as we got before. So closing it and sharing the results of the first poll now.
Oh, and could you read them?
Oh, sure. Didn't know you can see them. So we've got 20% saying that 1 year for the time scale, 51% saying 2 to 3 years, 12% saying 4 years, and then 17% saying 5 or more years.
Thanks. Yeah, so thanks for participating in that. So as you can see, for most people in the call, the controls ready idea sounds like it would not fit at the moment. So it would need some changes to some sort of regulations or legislation or something. So this is a visual representation of the key takeaway from this research. To the extent that energy savings around 2030 will be valuable, incentives today for uncontrolled LED lighting are cutting off significant opportunities for energy savings in the 2030 timeframe. Efficiency programs with 2030 goals for decarbonization can reduce their risk by not being like this guy in the red shirt, whose incentives for uncontrolled lighting in his right hand are cutting off his opportunities for future energy savings in his left hand that he is depending on. From a more positive perspective, I want to talk to you about 3 ways to manage the risk of investing in lighting efficiency incentives today. And I want to start by telling a story. Imagine, if you will, that some of your friends have recently purchased a used hot air balloon. They are very excited because they got a really good deal on it. They've persuaded you to accompany them on their maiden voyage because they admire your attention to safety and cautious, careful risk management, which has often saved the 3 of you from unfortunate circumstances in wild schemes that they've dreamed up. As you imagine what this first trip will be like, you think about a few things that you'll need to be prepared for what you might encounter on this new adventure. First of all, you want to make sure to have foolproof controls on the burner. So you'll be able to make the balloon go higher by running the burner and lower by turning off the burner. You realize that for takeoff and landing, you'll need plenty of rope. As you research the topic, you realize that you could simply take off and see where the wind blows, but that's probably not the best idea. If you want to choose your direction, you can select a particular altitude with a particular wind speed and direction, but only if you have a good weather app on your phone to take advantage of information from nearby weather stations. After a bit more research, you find a hot air balloon club and join it. After meeting some of the members and getting some support and helpful suggestions, you and your friends enjoy your first of many successful hot air balloon flights with other members of the club. Now, imagine, if you will, that the world has recently bought into the idea that the entire electricity grid needs to be decarbonized rapidly with emissions cut in half by 2030 at the same time as the space conditioning and transportation sectors are being electrified. Your energy efficiency program has been recruited in this endeavor, especially because you bring attention to safety and cautious, careful risk management, which has often saved your organization from unfortunate circumstances and wild schemes that other departments have dreamed up. Just as the controls on a hot air balloon prepare you to enjoy a day of fun, controls on all of your incentivized lighting projects will prepare you well for a future of energy savings. To deliver the most energy savings between now and 2030 in an affordable way, all incentivized lighting projects today should include network lighting controls, even though this might increase the cost per kilowatt hour saved this year and thus decrease the volume of first-year energy savings. One straightforward way to require lighting controls on all incentivized lighting is to only offer lighting incentives for luminaires with luminaire level lighting controls, or LLLC, where an embedded sensor and a wireless network radio is required in every luminaire. When you first tried out your friend's balloon, you briefly lost control of the burner and were very grateful to have a rope anchored to the ground so you could sort things out before taking off. Likewise, if you find that network lighting controls are not yet feasible on all of your incentivized lighting projects today, then all of those projects should at least include controls-ready luminaires to preserve the possibility of adding controls in the future. This may need regulatory updates to support a relatively small additional cost today that will deliver no additional energy savings unless controls are actually installed at some point in the future. And finally, how can you connect with powerful external forces to deliver a higher level of performance and opportunities? That, of course, would be integration between network lighting controls and HVAC. For better future-proofing on incentivized lighting systems and also incentivized HVAC systems, efficiency programs could promote a pathway for occupancy communication from the lighting system to the HVAC system in buildings where that is feasible. Also, programs could provide incentives for system integrators to review designs before installations and solve problems after installation. To summarize, this work indicates that lighting incentives will provide more long-term energy savings if all incentivized lighting projects have network lighting controls. If that's not possible, then at least they are controls ready with standardized digital D4I drivers and standardized Zaga sockets, and NLC HVAC integration is encouraged on projects where that is feasible. If you're wondering what exactly is involved to have lighting controls on all projects and to support NLC HVAC integration, please consider looking for a group of like-minded organizations so you can enjoy learning together how to navigate this new world of rapid decarbonization. For instance, the DLC Lighting Controls Summit is coming up in a few weeks in Detroit. The morning will include a panel and a working discussion session to develop ways that the DLC could support NLC HVAC integration in cooperation with efficiency programs. The afternoon will focus on DLC's new program to support network lighting controls in small and medium-sized buildings with easily scaled prescriptive incentives. We will not have any hot air balloons, but we do have some fun activities planned as well as plenty of networking opportunities. So if you're interested, registration is still open. So please check out our website at designlights.org to register. That concludes the main part of the presentation, but I also want to mention that Matthew Sachs, the lead author of the report, will present a poster about this work at the ACEEE Conference on Energy Efficiency as a Resource in Philadelphia in mid-October. You can find an 8-page summary of this research on the DLC website under Resources, and a recording of this webinar will be posted in the next few days at the same place where you registered. The full research report is available to DLC member efficiency programs as a benefit of DLC membership, and also by request for interested regulators and policymakers. And now we will move to questions and answers. Thank you.
Great, thanks, Levin. Very good presentation, a lot of information in there. So definitely stress on people to take a look at the summary report because it will help you to further understand the presentation that Levin conducted today. So there are a couple questions that have come in. Levin, I'll have this first one for you. Has to do with digital drivers and controls, or in controls ready. So the question is, why is it important or necessary for the NLC system to use digital drivers as opposed to analog drivers?
That's a great question, and there's a couple of reasons. First of all, a digital D4I driver has a lot of integrated stuff in it. So it when you add digital lighting controls, you've already included part of the system in the driver. So adding the rest of the system is more straightforward and easier. Also, with digital standards, products from different manufacturers are compatible to work together via the standard. This is very different from the old analog 0 to 10 volt dimming, where to get a foolproof installation of a network lighting control using 0 to 10 volt dimming, many people find that the safest way to go is to stay with one manufacturer and not mix and match any parts from different manufacturers, because each manufacturer has little tweaks and proprietary things that they do to keep that analog system working well. So basically, it gives you a lot more flexibility in terms of the control system that you can add later, and the chances that it will work smoothly without unexpected hiccups from unexpected analog things happening.
All right, thanks, Levin. Questions are flying in now. I think people are, it's all settling in, and it's like, okay, now let's go. So here's a question around plug load. With plug load being disappointing, will plug load controls be removed from code stipulations?
That's a good question, and that I would say I couldn't say. This research does not have the definitive final answer on that result. That was the best guess. That was based on the best information we could find at the time. But I have not looked in detail at the work papers that support plug load control in codes, so I couldn't really say. What I could say is there were a few building types. I think in large office, it seemed like there was a bit of an impact from plug loads. But in most of the building types, it was difficult to find plug loads that weren't either already controlled with a sleep cycle, or, if they weren't already controlled, then were they happy being controlled? Were they still functional, where they provide the service needed if they were put under controls? So that's a good question. It may be I imagine there would need to be some new work papers developed to document that. If it is in fact true that plug loads have diminishing returns now that more and more loads are getting smarter.
So Levin, if I could add to that also, our report only looked at this, as you stated, from the incentive program perspective, and if incentives should be given. And so the focus on the plug load for us was incentives towards plug loads, where code is looking at it from a different perspective as well. So a lot of the things, we'll say the reasons why it is efficient already is because codes have driven a lot of that.
Thanks. That's an excellent point, Stuart. Yeah, to the extent that code has already driven it, then there's no additional savings for a new energy efficiency measure to come in and claim. Good point.
All right, next question, and I think you do have a little bit of this, Levin. You mentioned about D4I drivers, upgrading to D4I drivers versus analog drivers for controls ready. So is there a percentage or something like that that you have that says, here's how much the controls ready luminaire costs versus the standard, so like going from a 0 to 10 volt driver to a D4I driver?
I have a couple of data points on that. First of all, digital drivers in Europe are cheaper than analog drivers because that's what most people buy. In North America, analog drivers are cheaper than digital drivers because that's what most people buy. When most people get around to buying digital drivers, they are very likely to be cheaper than analog, just like in Europe. At the moment, they cost more because the market is very small and it's a special order item. And so it's difficult to get and they're not stocked, and it costs more in time and in money to get the digital driver. But that's only because the market is small. And given efficiency programs' role in market transformation, this is an ideal opportunity for utilities to help transform this market so that after digital drivers are required for incentives for a little while, they will become cheaper as the market grows based on volume.
Great. Yeah. Thank you, Levin, on that one. So along that same line, and again, this is an opinion, I guess, question, but wouldn't it make sense to incentivize only NLC systems that include D4I drivers? This way you're future-proofing, today for tomorrow.
Yes, that would definitely make sense. In fact, if I give this presentation again, maybe I should add that as another point. But yeah, great idea.
Okay, let's see. Just reading this one. This one's a little bit longer. All right, that one's more of a statement. Let's see. So, okay, there are active proposals in development to require broad HVAC lighting control integration in ASHRAE 90.1 2025, which is being worked on now, and IECC 2024. If these requirements are put into the energy codes and states adopt the codes, utilities would not be allowed to offer incentives for this. Is that right or wrong? And then how do you anticipate that this would affect the work that you're talking about?
That's a great question. That is true, and it varies by region. Some efficiency programs can pay incentives to help buildings come up to code, especially for a lighting retrofit. Other regions cannot pay incentives to help meet code. They can only pay to go beyond code. So that is a good, yes, that is a very relevant concern. in that in a few years, when that code goes into effect, now 2025 will be adopted and then ratified a few years later. So in terms of when it applies, it will be a few years later. But when that eventually applies, yes, that will stop some of these incentive programs. Ideally, incentive programs until that point could help expand the market and increase the market volume so that when that code hits, there are plenty of products available and plenty of contractors who know how to do the work. There is another question of, as society looks at electrification and decarbonization, are there any other sources of funding besides utility efficiency programs to drive the very rapid electrification and decarbonization that is needed? So even if some utility programs are not allowed to incentivize anymore once it's in code, there could very well be some other policy providing some other incentives because it's got to get done fast.
Yeah, codes and utilities, it's always a dance.
Yeah. But now with, for instance, with the IRA policy, if there's some follow-up on the IRA policy, that's a third player in that dance that might be able to provide more, another source of funding.
Good point. Good point. Okay, next question. How was the HVAC energy savings determined, and did the baseline buildings have setback controls already?
Yes, the baseline buildings have setback controls already. This is not setting back the HVAC to an unoccupied mode. It's called something like occupied standby. So at night, the building might go cold down to 60 degrees or something Fahrenheit. This mode is not going that wide. It's taking the regular set points. Maybe the regular set points vary between 68 and 72 degrees. And it just broadens them, maybe from 65 to 78, for instance. And it says, as long as no one's in the room at the moment, you can let the temperature drift a little wider, but you don't let it drift as far as it would if you knew the whole building was going to be unoccupied for the next day or something. It was determined with several conversations with Michael Meyer at Pacific National Labs, who has been running a series of case studies with Scott Hackle at Slipstream, and has published a few webinars about that. And so we checked out the webinars and then talked with him, and it seems like 30% is a reasonable number in the buildings that are where it's feasible. And that includes a range where some buildings are a lot more than that and some are smaller, but 30 is a good kind of medium range. And with acknowledging that some buildings are not suitable at all. So it's only 30, you start with a building that you think is a good fit, and then when you do it, then you're likely to get somewhere around 30%. And I believe there will probably be future publications from PNNL from that series of case studies, and possibly new case studies going into more details about those numbers.
All right, thanks, Levin. Another question here. You spoke briefly about high-performing cost-benefit results for NLC and HVAC together. Could you elaborate on what costs were included in this analysis? For example, lighting equipment, controls components, installation and commissioning, so
on. No, sorry. I think all of the above, but I would be taking a guess. I can get back to you on I can get back to the questioner later to get into those details, but I don't have them on the top of my head.
Okay. There are a ton of questions here, so I'm just trying to pull some that might be a little bit different. But for everyone that did send in questions, we will definitely reply directly to you with answers as well. Some of these are very opinion based, and some of these are technology based. So we may wind up, in some of the technology things, there were some very specific driver questions in here, which are not in our expertise, that we would reference you to some other websites or material as well. Do you see the need for utilities to have operations and energy efficiency groups working together to accurately value energy efficiency in the new decarb marketplace?
Absolutely. I think that would be wonderful. Any cross fertilization in utilities is a grand thing, starting with just having the HVAC efficiency folks and the lighting efficiency folks talking with each other. But yes, talking with operations would also be wonderful.
Yeah, I think that's one of the things that we're seeing, right? That there's a lot of different people that are involved in the work and the decisions that are going on. And it really does need to be a community to reach the goals.
Yeah, especially because there's some people in other parts of the utility who really care about those 20-year goals, or in the time range of 10 to 20 years. And energy efficiency can help them out a lot, but not if all the opportunities get cut off in the next few years before we get there.
Right. There are several other questions in here about the cost that was factored in, Levin. So, we'll definitely get back to people on those ones. Yeah. Like I said, some of these we're definitely going to have to do a little bit of thought to be able to respond to the questioners. Let's see, here's one for you. Are VAV boxes required as an HVAC equipment specification to be considered feasible in this study?
That's a good question. So a variable air volume box will help obviously vary the ventilation. So in order to get the ventilation savings, which was one color in those charts I showed, then you would need a VAV boxes. But you could still get the temperature savings even if you don't have a VAV box, right? Because you could let the temperature set points vary widely, even with constant air volume. You will not get any fan savings, but you will get savings from the temperature conditioning. So it helps, but it's not necessary.
Right. Okay, good. Does the recommendation for NLCs to be with all or controlling all LED, let me restart this, sorry. Does the recommendation on NLCs for all LED incentive programs preclude LED lamps and fixtures and other retrofits solutions in your opinion? So should NLCs for all preclude just straight up LED retrofits?
Well, there are a few smart lamps. You can install a lamp and it has its own little internal radio controller and dimmer. So it would not preclude them. It otherwise, if you're installing just a lamp, you need to find some other way to hook up controls to it. And so it would drastically reduce the incentives for those lamps And the reason is because if the lamps are not controlled today when they go in, they will still not be controlled for the next 10 to 15 years, however long they're there. So yes, it would make a big difference in the lamp market, but it would still make space for the very, very few lamps that already have smart controls embedded in them.
Yeah, so our goal is to have everything that's installed be controllable at a minimum. So you can either be controls ready or put it all in together. NLC upgrade, tying it in with the HVAC integration.
Yeah.
And that capability. Did you look into any of the challenges to actually institute NLC HVAC integration? I know that you had the working group that recently as well.
So based on this research, we realized we needed to, based on the research that I just presented, we realized at DLC that we need to look into this more. So we convened a working group over the summer and asked that very question. What are some of the biggest challenges, and which ones of them could DLC help address? And so I thank you very much for all the folks who participated in that working group. And we got some great results out of that. And then we're going to take those results in terms of our initial thoughts about what are some of the challenges and what can DLC do about it. And then we're going to work on that some more at the summit coming up in Detroit to work on that more. So yes, there are many challenges currently in NLC HVAC integration. The place where it happens anyway is in really large buildings with building management systems, because the reward is worth the difficulty of doing the integration. I've heard anecdotes that occasionally it gets done in smaller buildings, but it's generally difficult and doesn't happen regularly. Yeah, there are many challenges at the moment for medium and small buildings. As I mentioned, the big one is that it's not a plug and play solution. Every building needs its own customized software, and so you really need a great big building to justify the cost of writing that customized software. Everything is siloed, from the efficiency programs to the installers. In terms of HVAC and lighting is just two different universes, and establishing connections at any point in the chain between the incentives, between the installers, anywhere is a challenge.
All right. Yeah, the working group was very successful. And as Levin said, thank you to everyone that participated in that as well.
But let me add. So the fact that there are challenges means this is a great place for incentive programs to step in and help, right? If it was easy, everybody'd already be doing it. It's hard, and incentives could make a big difference.
Yeah, definitely. And to that point, and because we're at time here, Levin, so I just want to wrap up with two things. One is, to address the smaller buildings, to get to that plug and play, that the DLC is working on a pilot to address the small to medium sized buildings to get more NLCs installed. So if anyone's interested in or has a project that is starting and would like to participate in this pilot with us, please let us know. You can send to the info@designlights.org email that Levin had earlier, and we can give you some more information on that. And the other thing that I'll just bring up again is our control summit that will be at the end of the month in Detroit, where this subject will be further expanded on. And we would look forward to having all of you there to be part of that conversation. So with that said, and we are 1 minute over, we'd like to thank everyone for attending today. And Levin, thank you again for excellent presentation, and we look forward to hearing from everybody. So thanks very much. Bye.
Thanks.